Hello students, today we'll revise what is polarization and we'll find out relation between polarization and bound surface charge density. So very short and sweet topic today. To understand today's topic nicely, we need to recall the following points. First of all, we should be knowing the definition of polarization. So we know that polarization is defined as total dipole moment per unit volume of the dielectric. And we also know that if the bound charge on the dielectric is QB, then surface charge density due to this bound charge for dielectric is given as sigma B, which is equal to QB by A. So we need to know just these two things, and with the two things clear, we are ready to go. We know that when we insert dielectric between two plates of capacitor, because of the free charges on the plates of capacitor, there is some displacement of charges inside the dielectric, and as a result, we have non-zero electric field produced. Now, we have charges on the plates of capacitor and we have charges on the surface of dielectric also. So the charges on the plate of capacitor produce free surface charge density, which is given as sigma f is equal to qf by a. What is qf? Qf is the free charge. So whenever we talk about qf, we are talking about charges on the plates of capacitor. But at the same time, we also have charges on the surface of dielectric. And we know that these charges cannot flow, so we call them bound charges QB, and the surface charge density due to this bound charge is given as sigma B, which is equal to QB by A. So don't get confused between QF and QB. QF is the charge on plates of capacitor. Surface charge density due to QF is sigma F, and QB is the charge on the surface of dielectric, and it is bound charge, and density due to bound charge is sigma B. Now we know that polarization is defined as total dipole moment per unit volume, and where polarization is taking place, polarization is the phenomena taking place in dielectric. So the separation of charge is the induced dipole moment is the polarization phenomena. And how much is the total polarization? For that, we need to know what is the sorry total dipole moment. How do we define dipole moment? We know that dipole moment is charge into separation. So if I am talking about the dielectric, how much is the charge? So QB is the charge, and how much is the separation? So we know that separation is the width of dielectric. So in this case, I have D, because the dielectric slab is having width D. So I can say that QB on left side and QB on right side is separated by distance D. So I can say that polarization is QB into D upon A into D. A is meter square area of the plates, and D is the distance meter. So in denominator we have meter cube. And now on simplification we get polarization to be QB by A. But QB by A is sigma B. So we can say that polarization is nothing but bound surface charge density. Though there is a slight discrepancy here, because when you talk about polarization, that is total dipole moment upon volume, and dipole moment is vector quantity, isn't it? So polarization is vector quantity, whereas QB is charge upon area and it is scalar quantity. So to remove discrepancy, this contradiction, we'll introduce a term later on in the coming topics, but for now, we'll accept that polarization is surface charge density, and vector and scalar quantity issue will address we can say that polarization is defined as total dipole moment per unit volume, and when we insert dielectric, and if the surface charge on the dielectric is QB, then surface charge density becomes sigma b, and relation between polarization and surface charge density is P is equal to sigma b. The two are equal. Polarization is equal to bound surface charge density. So that was the topic. Thank you.